The continuous testing of the Starbase's suborbital launch has led SpaceX to finally launch the first Starship prototype on the orbital space as part of the company's first testing campaign. The Starship SN20 is one of SpaceX's most notable projects currently in development. It is the company's premier bet for fully developing a fully reusable spaceship that can carry any payload. Its design goals plan to transport up to 100 people or 150 tons into space at a time. Its fully reusable design, paired with Raptor engines that are liquid oxygen and methane, means astronauts can fly to Mars, refuel using the planet's resources, and either return home or venture out further. Starship SN20 was able to launch from its assembly line for the first time back in the third quarter. During its first attempt, the SN20 was able to fly from the Starbase launch site up through some kilometers of the South Texas Highway. In this initial examination, SpaceX already equipped Ship 20 with the anticipated Super Heavey Booster 4. This booster is essential to the following projects Elon Musk informed that their company will eventually run in the future, including the rocket's debut to the orbital flight. After the test, Ship 20 was again reconfigured in the Starbase for additional weeks. The latest update from Starbase confirmed that the Starship SN20 will be presented in 1 or 2 suborbital launch tests. These supporting tests will then be followed by a 6-week break to allow SpaceX experts to work through the upper stage of the estimated 50-meter spacecraft. These steps successfully passed a series of qualification tests that the previous SpaceX crafts were able to pass without recurring problems. SpaceX's 2 whole months of preparing the Super Heavy and Starship have borne fruit as the Starship SN20 presented unexpected fragile heat shield tiles. The ship's dramatic exhibition was explained by Elon Musk himself, saying that the tiles jetted by the spacecraft were due to the cold gas stuck in a high-pressure thruster. The loss of several heat shields supported the fact that the Starship SN20 was yet to meet the required pressure and cryogenics. The thermal contraction of the steel that takes place in an environment that has extremely low temperatures could significantly change the massive rocket's diameter and cluster the tiles all together. With the event, the Starship's own ceramic heat shield tiles are deemed fragile. Other parts were also found to shatter and chip off after they were attached to the Starship. What separates the Starship structure from traditional rockets is that SpaceX confidently mounted the heat shield directly with the surface of the propellant tanks, made of thin steel. This thin layer also serves as the cover for the rocket's overall airframe. The bold move was seemingly expected by the company's experts, and they had their robots weld the exterior issues. Starship's unique thermal protection system, or TPS, is surprisingly simple compared to the complex sheets that cover the entire International Space Station and Russia's Buran. SpaceX followed the mending of the sheet issues and seemed to have been resolved. As the Starship SN20 was recently able to perform a 9-hour test window, the loss of numerous tiles allowed the experts to identify the thermal and mechanical workarounds of the issue. However, if this problem persists, the TPS technology may hinder SpaceX projects in the future by redesigning their models and could push the launch away from the expected schedules. SpaceX appears to have delivered hardware that will eventually become part of the first 33-engine Super Heavy boosters to its South Texas Starbase factory. The giant coin-like structure was spotted arriving at Starbase. Unlike Falcon boosters, the latest variant of which relies on a structure known as the octaweb that's bolted together from dozens of structural elements. SpaceX has moved towards more monolithic thrust pucks for Starship and Super Heavy. Starship's central thrust puck is just 2 or so meters in diameter and designed to support the ship's 3 gimballing Raptor center engines. Super Heavy's puck is more like a giant steel coin that Starship's almost conical thrust structure, measuring some 5 to 6 meters across, but no more than a few inches thick. It's also designed to support a good deal more than 3 Raptors. In line with comments made by CEO Elon Musk in early July, SpaceX's newest Super Heavy thrust puck updates both figures, boosting the outer ring to 10 engines and inner cluster to 3 engines for a total of 13 Raptors. combined with a ring of 20 fixed Raptor boost engines installed on the inside of Super Heavy's aft skirt. A 13-engine puck will allow SpaceX to install up to 33 engines on the Super Heavy boosters. A Super Heavy booster with 33 engines installed could produce up to 6,100 tons of thrust at liftoff. Once SpaceX has qualified and ramped up production of next-generation Raptor 2 engines, Super Heavy's max thrust liftoff could jump to almost 7,600 tons, more than twice that of the current record holder, NASA's famous Saturn V moon rocket. At the most basic level, cryogenic tanking tests, whether with the Starship, Super Heavy, or test tanks and liquid oxygen, methane propellant, or neutral liquid nitrogen, are fairly simple. The vehicle is attached to pad systems, powered on and partially or fully loaded with cryogenic fluids. Once the desired test objectives are achieved or attempted, the vehicle is then detanked. Thanks to the fact that they're incredibly cold, minus 160 degrees Celsius to minus 200 degrees Celsius, or minus 260 degrees Fahrenheit to minus 330 degrees Fahrenheit, the LOX or LN2 starships are filled with quickly chilled and then thin steel tanks containing them. With no insulation to speak of, that supercooled steel then freezes water vapor out of the humid South Texas air, creating a layer of frost that generally follows the level of the cryogenic liquids in Starship's tanks. Throughout that process, those cryogenic liquids inevitably come into contact with ambient temperature Starship tanks and plumbing, white hot in comparison, and warm up, boiling off into gas as a result. A gaseous chemical is far less dense than its liquid form, meaning that the pressure inside the Starship's fixed tanks can rapidly become unmanageable, even after a small amount of boil-off. To maintain the correct tank pressures, Starship, like all other rockets, occasionally vents off the gas that forms. And thus, the two main methods of interpreting the hieroglyphics that are cryoproof tests, frost levels and venting. SpaceX has assembled the first and the second chopstick arms. When the structure and the Starbase orbital launch tower are ready, both will be mated to perform. Since this is a new idea and has never been tested before, CEO Elon Musk has previously admitted that this experiment can fail while testing. But excitement is guaranteed while watching this happen in the real world, failure or success. We might be able to see all of this in action, as SpaceX is trying hard for the first Starship orbital flight test before the end of 2021, pending approval by the FAA. And that's all for today. If you want to be updated with the latest space and SpaceX news, subscribe to the channel and hit the notification button. Thank you so much for watching. Keep yourselves safe and healthy until we meet next time.